Forget distant galaxies. Forget the exoplanets drifting thousands of light years away in the endless dark. The most profound and potentially terrifying mystery of modern astronomy isn't hiding at the edge of the observable universe. It is sloshing around, right in our own cosmic backyard. For decades, humanity has stared at Europa, one of Jupiter's massive moons, and seen only a dead, heavily scarred billiard ball of ice, suspended in the lethal radiation belts of the gas giant. But beneath that bright, fractured shell of water ice lies an abyss. A pitch-black, global ocean containing twice as much liquid water as all of Earth's oceans combined. For a long time, the question was simple. Is this endless dark ocean a sterile, freezing tomb? Or is it a dynamic chemical cauldron capable of supporting life? We didn't know. Until now. When the James Webb Space Telescope finally locked its infrared mirrors onto Europa, it looked past the blinding glare of Jupiter and found something that is sending shock waves through the scientific community. It found the impossible. To understand the sheer magnitude of what the James Webb Space Telescope just discovered, you have to understand the brutal reality of Europa itself. The moon is locked in a relentless, violent gravitational tug-of-war. As Europa orbits the gas giant, Jupiter's massive gravity physically stretches and squeezes the entire moon. This intense process, known as tidal flexing, acts like an engine, generating enormous amounts of internal heat. It is this friction that keeps a massive, subsurface ocean liquid beneath a frozen crust. But for astrobiologists, liquid water is only one part of the equation. To have life as we know it, you need chemical building blocks. You need a way for the surface to interact with the dark abyss below. That is exactly where the James Webb Space Telescope stepped in. Astronomers pointed Webb's incredibly sensitive, near-infrared spectrograph at a highly specific region of Europa's surface known as Terra Regio. Terra Regio is what scientists call chaos terrain. It is a geologically young, highly disrupted area where the smooth, icy crust has been violently shattered, broken apart, and frozen back together in jagged blocks. It looks as if the subsurface ocean literally punched its way through the ice and bled out onto the surface, and scattered across this chaotic, shattered landscape. Webb detected a massive concentration of a specific molecule, carbon dioxide. On Earth, carbon is the fundamental backbone of all known biology. Life thrives on chemical diversity, and carbon is the ultimate building block. Finding it heavily concentrated on Europa is a monumental event. But carbon dioxide is not naturally stable on the surface of Europa, because the moon is constantly bombarded by the intense, lethal radiation of Jupiter's magnetosphere. Any carbon dioxide left exposed on the ice should be rapidly destroyed. The fact that Webb can see it right now, highly concentrated in the geologically young fractured ice of Terra Regio, proves something terrifyingly profound. This carbon did not come from the outside. It wasn't delivered by crashing meteorites or passing comets. It came from the inside. The carbon dioxide that Webb detected was forged in the absolute darkness of Europa's subsurface ocean, pushed upward through the crushing weight of the ice shell, and deposited onto the surface on a geologically recent timescale. We are not just looking at a dead crust. We are watching the internal chemical heartbeat of an alien ocean bleeding through the ice. But the chemical story of Europa gets even more intense. While Webb was mapping the carbon, Another team of researchers was digging through decades-old archival data from NASA's Galileo spacecraft. Using modern advanced spectral modeling, they discovered something hiding in plain sight alongside the deep fractures of Europa's crust: ammonia-bearing compounds. Ammonia is a nitrogen-based molecule, which is another foundational pillar of life, crucial for the formation of amino acids and DNA. But in the freezing, brutal environment of Europa, ammonia serves another terrifyingly practical purpose. It acts as an extreme cosmic antifreeze. An abundant presence of ammonia can lower the freezing point of water by up to 100 degrees. This means the liquid water within Europa's crust, or the ocean itself, can remain slushy and mobile at temperatures where it should be frozen solid as rock. This toxic antifreeze is actively bubbling up from the shallow subsurface, keeping the icy shell dynamic and geologically alive. We now have proof of carbon welling up from the deep. We have evidence of nitrogen-rich ammonia acting as antifreeze in the shattered ice. We know the ocean is massive, and we know it is actively interacting with the surface. The pieces of the biological puzzle are assembling themselves in the dark, and we are not waiting around to find out what happens next. In October 2024, NASA launched the largest interplanetary spacecraft in its history, the Europa Clipper. But Clipper is not flying into the dark alone. In April 2023, the European Space Agency launched its own flagship mission, JUICE, to hunt for habitable environments in the Jovian system. A literal robotic armada is now speeding through the void. When Europa Clipper arrives in April 2030, it won't just orbit the moon. The radiation environment is too lethal for that. Instead, it will orbit Jupiter, plunging in and out of the danger zone to perform 49 daring, low-altitude flybys, skimming just 16 miles above Europa's shattered crust. It will look through the ice. It will taste the escaping gases. It will map the chemical scars left by an ocean we cannot see. We used to look at the stars and wonder if we were alone. But the answer to the greatest question in human history might not be waiting in a distant, impossible galaxy. It might be waiting in the freezing, pitch-black waters of our own solar system, trapped beneath miles of shattered ice, just waiting to be found.